Hi and Assalamualaikum. We are from Group 6. Today we would like to present our presentation titled The Ratio Between Two Population Variants in F Distribution. So first of all, I would like to introduce myself and my group member. First, my name is Nordina Tasha binti Asmadi. The second group member is Anis Shuhada binti Ishaq. The third group member is Nurul Nashwa binti Khairuddin. The fourth group member is Nur Fatihah binti Mustafa, and last is Muhammad Taufiq Hidayat bin Rosli. Okay, let's start with the introduction. What is the ratio between two population variants in F distribution? The F distribution is simply a ratio of two variants. Variants are a measure of dispersion, or how far the data scattered from the mean. The F distribution is always used to compare two variants S1 and S2 by dividing them. Now let's look at the facts about F distribution. First one, the curve is not symmetrically but skewed to the right. Second, there is a different curve for each set of distribution function. Third, the F distribution is greater than or equal to 0. Fourth and last, as a degree of freedom for a numerator and for the denominator get large, the curves approximately to the normal.
Hi, my name is Anshada and I'll be continuing this presentation with equal in chapter 2. And as we know that in the theorem, F equal to U over R1 divided with V over R2. That follows F with degree of freedom R1 and R2. The probability distribution function of the W is equal to F distribution with R1 and R2 degrees of freedom, where U and V are independent chi-square variables with R1 and R2 degrees of freedom respectively. And as we can see in the slide, U follow chi-square R1 as degrees of freedom, and V follow chi-square R2 as degrees of freedom. And to prove, for example, there's two population, and U as the first population with N1 minus 1 times sample variance 1 over variance 1 that follow chi-square N1 minus 1 as the degrees of freedom. The second population, N2 minus 1 times sample variance 2 divided with variance 2 that follow chi-square N2 minus 1 as the degrees of freedom. And we substitute this into F formula and we simplify until we get variance 2 times sample variance 1 over variance 1 times sample variance 2 that follow F distribution with degree of freedom N1 minus 1 and N2 minus 1. And that's all from me, and this presentation will be continued with Fatihah.
My name is Fatihah and I will continue for the confidence interval for ratio of two population variances. The first one we have is S1 square over S2 square. This denotes as a ratio sample variance, which are the point estimate of two population variances. Number 2, sigma square 1 over sigma square 2 denotes as the ratio of the population variance, which is to compare the variances of two normally distributed population. Number 3, all the possible sample size N1 and N2 are selected from their respective population. Last but not least, number 4, if it is given that sigma square 1 and sigma square 2 are the variances of normal population, hence the interval estimate of sigma square 1 over sigma square 2, which this is the ratio of population variance, is given by F statistic, which is noted below, which this F statistics follows the F distribution with degree of freedom of n-1 and n-2.
Now we continue to derive confidence interval for ratio of two population variants. Step 1 is identify the function random variable involving parameter of interest. We get F equals to sigma 2 squared S1 squared over sigma 1 squared S2 squared. The second step, determine the distribution of partial random variable. We get f equals to sigma 2 squared s1 squared over sigma 1 squared s2 squared, followed by fn1 minus 1 and 2 minus 1 degree of freedom.
Okay, for step 3, I will continue. So for step 3, find the critical value of both ended side of the distribution. So as you can see here, this is the form that we already created based on the theorem before. And this quantity in the middle is the random variable because s1 squared over s2 squared is a random variable. But for sigma 2 squared over sigma 1 squared, they are not random variable, they are fixed value. And for the left side and right side, as you can see, for the left side, f sub 1 minus alpha over 2 is the n f or sub alpha over 2. They are the quartiles from the f distribution. For f sub alpha over 2, the f value that has an area to the right, as you can see from this graph. But for f sub 1 minus alpha over 2, this is the f value that has an area to the left of alpha over 2. Next, we will find the probability that the quantity in the middle takes on a value between these two f value is 1 minus alpha. Okay, so for step 4, we already simplify it into this form. So as you can see, we already turned the both side, which is the f sub 1 minus alpha over 2 and f alpha over 2 into a reciprocal form. So as you can see, this is the we already simplify it into this form. And next, we change the inequality sign because as you can see here, 1 over f sub alpha over 2 is much more smaller than 1 over f sub 1 minus alpha over 2. So we need to change the position. Then we put it in opposite position, and we will get this form. Next, for step 5, we need to subject the parameter of interest in the middle of the inequality. So we know that we want to find the sigma 1 squared over sigma 2 squared. So we need to multiply both sides with s1 squared over s2 squared. So this is form that we already after we multiply with s1 squared and s2 squared. So for step 6, as shown here, we already get the sigma 1 squared over sigma 2 squared, and also as you can see here, 1 over f sub alpha over 2 and f sub alpha over 2. This shown the bound of the interval. So for 1 over f alpha over 2, it's shown that that is a lower boundary of the interval, and for f alpha over 2, it's shown that that is a upper boundary of the interval. And therefore, this is why this interval represent 1 minus alpha multiplied with 100% of confidence interval for sigma 1 squared over sigma 2 squared.
So we move to the example. This is our example. The data in the table below shows the amount of the contract for the two brand of soft drink, which is Pepsi and Coca-Cola, in RM1000 in the selected school. Construct a 90% confidence interval for the ratio of two variances. Interpret your findings. So we can look at the tables. There is two brand of soft drink, which is Pepsi and Coca-Cola. 7 for Pepsi, 4 for Coca-Cola. So variance for Pepsi S1 squared is 255.9424. variance for Coca-Cola S2 squared is 313.6667. So the alpha value is 0.1, alpha over 2 is 0.05. So for the F value, alpha 0.05, V1 equal to 6, V2 equals to 3 is 8.94. And for F value 0.05, V1 is 3 and V2 is 6 is 4.76. So we put all of the values in the formula of F distribution. So we get two value, which is 0.09128 and 3.88417. So alpha sigma square 1 over sigma square 2 so the value is between 0.09128 and 3.88417. Therefore, at 90% confidence interval for the ratio of the two variances for the amounts of the contract for the two brand of soft drinks, which is Pepsi and Coca-Cola in RM1000 in a selected school, is between 0.09128 and 3.88417. That's all from us. Thank you.